Today we're going to talk about chemical bonding. Anytime a chemical reaction happens, chemical bonds are either being formed or they are being broken. And so in talking more about chemical reactions, we are going to be taking a look at how bonds play a role in that. We're going to start by answering the question, what are valence electrons? We've talked about valence electrons without actually using that term. Valence electrons are those electrons that are in the outermost energy level or the outermost shell. They're held the most loosely. We say that because the closer you are to the nucleus of the atom, the more tightly those electrons are held. They're less likely to leave that atom. The electrons that are in the outermost shell are more likely to leave an atom and perhaps go to another atom instead. So valence electrons are the electrons that are in that outermost shell. Question 2, how is the reactivity of elements related to valence electrons? Well, really the reactivity of elements has everything to do with valence electrons, because the number of valence electrons that an atom has, that's what determines the ways in which the atom is going to bond with other atoms. Number 3 asks us, how can you use the periodic table to predict valence electrons? It's actually kind of handy. We've just finished talking about the periodic table. And we can actually, if we want to know how many valence electrons a particular element has, sometimes we can look at the periodic table to tell us. If you look at groups 1 and 2, here's group 1, here's group 2. Group 1 has 1 valence electron, so every element in group 1 has 1 valence electron, 1 electron in the outer shell. Group 2 has 2 valence electrons. Skip past the transition metals and go to group 13. In groups 13, 14, 15, 16, 17, and 18, if you subtract 10 from that number, you'll get the number of valence electrons each of those elements have. So in group 13, all of those elements have 3 valence electrons. In group 14, they have 4 valence electrons, and so on. The only exception to that in groups 13 through 18 is helium. Helium only has 2 valence electrons because it only has 1 electron shell, or 1 electron energy level. Unfortunately, the elements in the middle of the table, the transition metals, there's really no pattern. We certainly can figure out how many valence electrons each element has, but there's no pattern to it. Here's a diagram that shows what we call Lewis dot diagrams, and we're going to talk a little bit more about those in a few minutes. What makes atoms unstable? Well, what makes them unstable is having valence electron shells that are not completely filled. In order for an atom to be stable, they need to have either no electrons in their outer shell, or they need to have 8 electrons in their outer shell. Either one of those situations, they will be stable and they will not want to react with other elements. Any other number of electrons, and they are likely to be reactive, in some cases very reactive. Or another way to say that is to say they are unstable or very unstable. Elements that have something between 0 and 8 electrons will either gain or lose or share electrons to try to either get to 0 or 8, because they want to be stable. What is chemical bonding? Well, chemical bonding is when 2 or more atoms join together to form a brand new substance. Why do atoms bond? Well, this goes back to question number 4, which said what makes atoms unstable, because the reason why atoms bond is they want to be more stable. That's why these reactions, these chemical reactions happen. It's the atom's attempt to become stable, to have a valence shell that has either 0 electrons or 8 electrons. What is a chemical bond? Well, the actual bond itself is not something you can see, touch, anything like that. It's not a thing. It's a force. It's an attraction, kind of like magnets. attract each other. And this force holds the two atoms together. That is what a chemical bond is. For example, we have sodium, which we know is a soft whitish metal. We've talked about this before, and we can combine that, or if sodium gets close to chlorine, then we have a reaction that happens where bonds are formed, and we end up with NaCl, sodium chloride, otherwise known as table salt. Question 8 asks, what are 3 ways that atoms can form bonds? Essentially, what are 3 different kinds of bonds? These are the 3 that we're going to focus on. There are some subsets of these bonds and things, but we're going to focus in on what's called ionic bonds, covalent bonds, and metallic bonds. And we're going to start with ionic bonds. Question 9 asks, how does an ionic bond form? Well, ionic bonds form when valence electrons from one atom get transferred to another atom. When that happens, the atom that lost an electron becomes positively charged because now it has one less negative charge. It has more positives than negatives. The atom that gained an electron, picked up that electron, becomes negatively charged because now it has more negatives than it does positives. So you have a cation and an anion forming, and those two ions, those two opposite ions, are attracted to each other because we know that opposites attract. Here's an example, again, using sodium and chlorine. You can see from the dots there that sodium has one valence electron. It makes it very unstable. It would like to get rid of that valence electron. Chlorine, on the other hand, has 7 valence electrons and would like very much to steal away one electron from somewhere else in order to get to 8. Sodium is more than willing to give one up. Chlorine would love to take one. So when sodium loses its electron, it becomes positively charged. Chlorine gains that electron, becomes negatively charged. Now you have a positively charged sodium, a negatively charged chlorine, and opposites attract and they form a bond. These ionic bonds can also help to form crystals. You might remember if you were here in 6th grade that we made crystals from salt water and alum water and Epsom salt water. We put them in we put drops of those solutions into a little glass dish, a watch glass, and allowed them to dry, and crystals formed. The reason for those crystals forming is because of the way that the sodium and the chlorine bond together. They actually form these box-like structures. All right, a little chemistry humor for you. What do you call a chemical bond that is sarcastic? An ironic bond, of course. All right, moving on. Let's take a little bit closer look at ionic bonds. Here again, we have the sodium, we have the chlorine. Sodium with 1 valence electron, chlorine with 7. Sodium loses its valence electron, chlorine gains it. Sodium now has a positive 1 charge, chlorine a negative 1. They attract each other and form the bond and form sodium chloride. Also happens with magnesium and oxygen. Magnesium has 2 valence electrons, oxygen has 6. We now have a positive 2 magnesium atom, a negative 2 oxygen atom when magnesium gives up its 2 valence electrons to oxygen, and those two attract, and they form magnesium oxide. Happens again with magnesium and chlorine. This is a little bit different, however. Chlorine only needs 1 extra electron. Magnesium would like to give up 2. It doesn't have any interest in giving up just 1. It needs to give up 2. So instead, if a second chlorine atom were to come into the picture, which also has 7 valence electrons, of course, then magnesium can give 1 to each. A bond forms when magnesium has a positive 2 charge. The 2 chlorines each have negative 1, and we end up with a balanced compound of magnesium and chloride, two chlorines to the one magnesium. Also happens with aluminum and oxygen. Here you can see it happens in a ratio of 2 to 3. Take a look at what happens to the aluminum valence electrons and how this bond forms. You can see this is now balanced, and we end up with Al2O3. The little 2 after the Al, aluminum, means that there are 2 aluminums. The little 3 after the O means that there are 3 oxygen atoms. So it always forms in that ratio. Question number 10, what is a compound? Well, we've talked about compounds quite a long time ago, back when we first started chemistry, but a compound is a substance that's made up of 2 or more elements that have bonded together. And the properties of that new substance are completely different from the properties of the original substances. Question 11, what is a chemical formula? Well, it's basically just a shorthand way of writing out these different chemicals that make up our world, these different substances that make up our entire world. Here we have H2O. I think we're all familiar with that chemical formula. It means that there are 2 hydrogen atoms and 1 oxygen atom in every molecule of water. We also have O2 here. Oxygen gas that we breathe is actually 2 oxygen atoms that are bonded together. The oxygen we breathe is not just single oxygen atoms, but instead it's a whole bunch of oxygen molecules, diatomic molecules, where you have 2 oxygen atoms that have actually bonded together. Glucose, a type of sugar. There are lots of sugars out there. There's glucose, lactose, fructose, sucrose, and various other ones. Glucose is one kind of sugar. That one, its chemical formula is C6H12O6. So in every glucose molecule, there are 6 carbons, 12 hydrogens, and 6 oxygens. When we took our element quiz, you'll remember I was pretty specific in saying that you needed to write those formulas correctly, starting with a capital letter, and if there was a second letter, it needed to be lowercase. That is because we need to be able to communicate using these symbols, and you'll see here we have 3 symbols that are very similar, but actually represent very different things. Capital C, lowercase o, is cobalt. You know that from your quiz. Capital C, capital O is carbon monoxide. The capital C tells us that's carbon. The fact that the O is capital tells us it doesn't go along with the C. It's not cobalt. Instead, it's carbon and oxygen. Every time you see a capital letter, you're starting a new element. So carbon and oxygen, in this case, there's 1 atom of each, which is carbon monoxide, a poisonous gas. CO2, stick a little 2 after that oxygen. Now we have 1 carbon and 2 oxygens, which forms carbon dioxide. Also a colorless, odorless gas, not quite so poisonous. It's not great for us and can eventually suffocate us if we can't get oxygen, but it is not poisonous. Here's a couple more formulas. NaCl, sodium chloride, table salt. And then magnesium chloride, MgCl2. 1 magnesium, 2 chlorines. Here's another list of just some fairly familiar types of compounds. You'll probably see some of these here and there as we talk more about chemical equations and things of that sort. We know water, we know carbon dioxide. Methane, CH4, so it's carbon. 1 carbon, 4 hydrogen. Propane, C3H8, means that there are 3 carbons and 8 hydrogens. Here's another sugar. This one is sucrose, C12H22O11. So 12 carbons, 22 hydrogens, and 11 oxygens. That's a pretty large molecule right there. And then you can see some of the others as well. Question number 12, we're moving away from ionic bonds now and on to covalent bonds. Question number 12, what is a covalent bond? I think actually we'll get to